Hi, welcome to a new session of Circuits and Networks. In today's class, we'll once again deal with network theorems. We are going to see all the theorems when we employ to a particular circuit, whether we are going to get the same answer or not. For example, this circuit here, it is reduced to Thevenin's equivalent circuit, and we have to make sure that the current which is flowing in this circuit is equivalent to the circuit which is we have drawn with the help of Thevenin's equivalent. How to do this, we are going to see in this further session. So as I told you, I have selected this problem and we need to obtain the value of current in 1 ohm. Okay, that is current through AB. We can use mesh analysis, you can use node analysis, superposition theorem, Thevenin's theorem or Norton's theorem. And the rest of the theorems you can cross verify after completion of all these different approaches and comment in the chat box whether you are going to get the same answer or not. So for the first thing, we are going to will do the analysis using mesh mesh analysis. That is what we're going to do here. So we have selected the same circuit and we have imagined three loops, that is IA, IB, IC. All the loop currents are flowing in clockwise direction. So this is our first assumption. Moreover, if at all you observe carefully, 2 amperes is the current source which is shared by loop current IA as well as loop current IB. So hence, this particular circuit with 2 amperes, it becomes a super mesh. Okay. So how to frame the equations for super mesh? We are going to see here. So first you select the inner loop. Inner loop you can see IB, IA, both are flowing in clockwise direction, whereas 2 amperes that is flowing from bottom to top. So I can say that IB minus IA is equal to 2 amperes. So this is the first assumption current we have selected with the help of super mesh. And now select the outer loop which is connected to loop 1 and loop 2. So here you can see the voltage is minus 12 volts plus 6 IA, that is the outer loop of the super mesh, plus 6 IB. We are continuing with the concept of super mesh. That's why we have directly taken the value of 6 IB over here as a drop over here, plus 4 IB minus IC. So it's another drop which is pertaining to this super mesh. That is equal to 0. Reframing this equation, I'm going to get 6 IA plus 10 IB minus 4 IC equal to 12. So this I'm treating as equation 2. Now I'll go with the third loop. The third loop is nothing but the loop. This is IC. So 4 IC minus IB, assuming this loop to be the dominating when I am considering the third loop. So IC minus IB plus 1 IC equal to 0. So reframing the equation, I'm going to get minus 4 IB plus 5 IC equal to 0. This I'm treating as equation 3. So just you need to solve equation 1, 2 and 3 such that we are going to get the value of IA is equal to minus 0.125 amperes, IB equal to 1.875 amperes and IC is equal to 1.5 amperes. And what is our requirement? Our requirement is the current I which is flowing in 1 ohm. So that value is nothing but 1.5 amperes. I hope you understood how we have solved this problem using mesh analysis, especially super mesh analysis. Next, we'll go with the node analysis. So you have to identify two nodes like here B1 and B2 and apply KCL over this node 1 and node 2 and you'll get the solution for B1 and B2 and I is nothing but V2 by 1 ohm. That is the catch over this particular approach. So we are applying KCL at node 1. We are going to get V1 minus 12 by 6. That is this branch current. Then you have minus 2 which is coming towards V1 plus V1 minus V2 by 6, assuming this node to be the dominated when we are considering with the node B1. So simplifying this equation, I'm going to get 2V1 minus V2 equal to 24. Let me frame as equation 1. Similarly, applying KCL at node 2, we are going to get V2 minus V1 by 6 plus V2 by 4 plus V2 by 1 equal to 0. It's nothing but assuming this to be the dominating node when I'm considering with node 2. So simplifying this equation, I'm going to get V1 is equal to 17 V2 by 2. So just you need to solve equation 1 and 2 this aligned in Roman fashion and you're going to get the value of V1 which is 12.75 volts and V2 is equal to 1.5 volts. And what is the requirement? Our requirement is I is equal to V2 by 1, that is 1.5 by 1 which is nothing but 1.5 amperes. The same answer we got using mesh analysis or super mesh analysis. Now, in the third approach, we are going to go with the actual theorem, that is the superposition theorem. So, in superposition theorem, you need to make one source active at one time, and you need to calculate the current corresponding to that particular active element. And similarly, you have to go with the next approach, that is the consider another active element at a time and calculate the corresponding current. And finally, you sum up the two currents which are due to individually active elements, and that current should be equivalent to the total current which is flowing in the load requirement. Here 1 ohm we are considering as the load requirement. So I am making first 12 volts active and 2 amperes as inactive. So 2 amperes is the current source that is inactive. So you have to open circuit it, and 12 volts it is active. So you have to consider 12 volts for the given circuit. So this is how I consider the 12 volts and I have removed 2 amperes. Now we need to consider the current in 1 ohm. So that I am treating as current I1. Okay. So the main current would be flowing through 12 volts source. And you can observe here 4 and 1 are in parallel. When they are in parallel, the value of 4 parallel to 1 will leads to 4 by 5, or that is roughly equal to 0.8 ohms. So if at all we need to calculate the value of current in this parallel circuit, that is how we need to calculate the current, because the total current would be obtained from 12 volts that will be traveling through this parallel combination. So 12 volts I have taken as it is, 6 and 6 I have added, so it becomes 12 ohms, and this parallel combination reduces to 0.8 ohms. With the help of this reduced circuit, I can calculate the value of current which is flowing is 0.8 ohms. What is that? 12 divided by 12 plus zero point 0.8. So it becomes 0.9375 amperes. In fact, this is the reduced model of this circuit which we have framed once again over here. So I have just elaborated 12 as 6 plus 6. So the current which is flowing in 0.8 is 0.3 0.9375 amperes, and the same current it is flowing over here. So I hope you understood how we have obtained the current with 12 volt source for this parallel combination. But what is the requirement? Requirement is I1. So for the parallel combination, from current division rule, when you have two resistors are in parallel, you can get the value of current IA or IB. For example, I require the current IB. IB will be equivalent to I total multiplied with opposite resistance. For RB, opposite is RA divided by RA plus RB. So this is how we calculate the value of current using current division rule. So here our requirement is I1. So IB we are considering as I1. I1 would be equivalent to, what is the total current we got? 0.9375 amperes. For that current, what is the opposite resistance? 4 ohms is the opposite resistance, divided by 4 plus 1. So it becomes 5. So this becomes 3 by 4 amperes. So this is our first requirement, and that is considered as equation 3. Okay. Now with the same superposition theorem, I am making 12 volts inactive and 2 amperes as active. So whenever you have 12 volts or voltage source, we need to short circuit it in order to make it inactive. So here you can see 12 volts is shorted, so it made inactive, and 2 amperes is considered as the actual current source. And again, with the proper approach, you see 4 and 1 are in parallel, so it becomes 4 by 5, that is 0.8. So I can reduce this circuit to this circuit. So again, from the current division rule, I can get the value of total current which is flowing in which is flowing in combination of 6 plus 0.8 ohms. So that's considering that current as Ix here. In fact, that will be the total current value. So the total current would be equivalent to same current division rule you apply. You can see total current is 2 for this particular circuit. Opposite for 6.8 is 6. So that is taken as opposite resistance divided by 6.8, that is the same branch resistance plus 6. So this becomes 15 by 6 amperes. So that is the total current Ix over here with the help of 2 amperes, which is the actual current. That is the source current. Fine. But what is the requirement? Our requirement is this Ix which is flowing, that has to be supplying the same value of, it has to give the total current to 4 and 1 which are in parallel. So I am considering that current as I2. So I2 would be equivalent to, the total current is Ix, so 0.9375. Opposite for the parallel combination would be 4, because I2 it is flowing in 1 ohm, so the opposite will be 4. So 4 divided by 4 plus 1, that is 5. So this two are in parallel, that is why the current which you obtained here, it is once again 3 by 4 amperes. So considering equation 3 and 4, we are going to get I is equal to the sum of the total currents. So that is 3 by 4 plus 3 by 4, which is equal to 1.5 amperes. So you have seen whether it is node analysis or mesh analysis, we got the same value of current, that is 1.5 amperes. Next, Thevenin's theorem. Same problem, Thevenin's theorem. For this, we need to find out V Thevenins and R Thevenins. First, you remove the load, that is 1 ohm from the main circuit, and we need to find out V Thevenins and R Thevenins. For that, what we need to do? First, we consider the V Thevenins. For this, this is the circuit we have written here, and here we have to obtain the Thevenin's voltage as the open circuit voltage across 4 ohms. So in fact, this becomes as this circuit. Just we are considering the open circuit conditions over here, and I'm taking a node voltage V. With this, I'm going to get the actual voltage which is present over this particular node, that is the V. So V would be obtained with the help of reframing this equation as 15 volts. Once we are done with 15 volts, I need to calculate the value of current which is flowing in 6 and 4. So the current which is flowing in 6 and 4 combination, that is considered as I. So I will be V by 10. Why V by 10? 6 plus 4 is 10. So that is the current which we require. Why we require this current? Because we need to find out the value of voltage across 4 ohms. So voltage across 4 ohms would be equivalent to current multiplied with the resistance. Anyhow, we are going back to the main circuit of the Thevenin's voltage. So here you can see VTH is equal to 4 into I. Just we have calculated the value of I, that is nothing but 1.5. So this gives you the value of open circuit voltage as 6 volts. Then Thevenin's resistance, same you consider the actual circuit by removing the load, and here we need to find out the R Thevenin's. For R Thevenin's, if at all you have voltage source, we have to short circuit it, and current source, if at all you have, we have to open circuit it. So how the conditions would be, here we have written. So here voltage source is shorted and current source is open circuited. Now clearly you can see 6 and 6 are in series, that is in parallel with 4. So 12 is in parallel with 4, which will give you the value of equivalent resistance as 3 ohms. That is also called as Thevenin's resistance. So once we are done with VTH and RTH, we can easily draw the Thevenin's equivalent network. So the Thevenin's equivalent network is given by this standard combination, that is voltage in series with resistor. So now we have to obtain the current value in 1 ohm. So the Thevenin's equivalent circuit would be 6 volts in series with 3 ohms. That is again in series with 1 ohm. So the circuit is closed. So current in 1 ohm can be calculated as VTH by RTH plus RL. So here VTH is nothing but 6, RTH is 3, and load current is 1. So I'm going to get the value of current as 1.5 amperes. Similarly, you cross check the result by Norton's theorem and comment in the chat box whether you got the same answer or not. So in today's class, we have seen what is node analysis, what is mesh and supermesh analysis, superposition theorem. The same circuit we have solved in many ways, and also we have solved with Thevenin's equivalent method. Then we have also seen what is the equivalent resistance means, and also we have seen the importance of current division rule. So all the basic network concepts are covered in this one particular circuit. I hope you like this class. Please share among your friends and subscribe to this channel, and please press the bell icon for future notifications. Thank you.